Hi everyone, welcome back to Health Economics. We are going to launch into Chapter 9 today, but I want to give you just a little bit of information about Chapter 9. Chapter 9, it's my favorite chapter in the book because we have some kind of cool results that I'm going to show you. But the caveat is that Chapter 9 is probably the most technical and the most mathy chapter in the book. So I'm going to, again, split Chapter 9 into 3 parts just to make sure you're getting it in kind of bite-sized pieces and I don't lose you. Hopefully you find it interesting. If you don't, then just hang tight for 3 parts of this chapter, and then after Chapter 9, the class is going to get much less mathy, and we're going to get more into institutional details of the healthcare system. Okay, so to just kind of set up Chapter 9 for you, what we've learned so far is that insurance is really handy because it can increase people's utility by taking risk out of their life. And so without giving people any extra money, we can just make them happier by giving them insurance, because now they're a little bit more relaxed when there's not this big volatility in what amount of money might be in their bank account if they happen to get sick and have to pay a hospital bill. Okay, the problem that we realized last chapter is that insurance is great, but insurance markets are prone to death spirals. And the reason for that is because of this thing called adverse selection, where healthy people drop out of the market. And so when an insurance company is out selling insurance policies, it's the sick, expensive people who want to buy the policies, and these people are not profitable for an insurance company. Okay, introduce Chapter 9. So Chapter 9 is we're going to embrace this reality of the world that adverse selection exists. So what's really true is that healthy people drop out of the market, and we need to just come to terms with that. But in Chapter 9, we're going to model the insurance market a little differently, and we're going to look specifically at how 2 economists, Rothschild and Stiglitz, modeled the insurance market. And the idea for their model or their roadmap is they said, we want to construct some kind of setup where we embrace the fact that adverse selection is there. Now let's try to model things so that that does not destroy the market. So they're trying to figure out, how do we keep a market from running into a death spiral? Given that, we need to incorporate into the model the fact that adverse selection exists. Okay, so what we're going to do in this chapter to begin with is we're going to move from the income utility space to the IHIS space to develop a framework for displaying multiple insurance contracts simultaneously on the same graph. So if you think back to last chapter, the graph that we were working with had utility along the vertical axis and income along the horizontal axis. And so what we're going to do now is we're going to change the labels on the axes. So now the vertical axis is going to plot a person's income when they're sick, and then the horizontal axis is going to plot their income when they are healthy. Okay, importantly, what we want to do is we want to create a plane where we can have one dot on the plane, and that one dot captures it encapsulates all the information regarding a single insurance contract that we previously used to have in the old setup. So in the old setup, sometimes we would have 2 dots to represent one insurance contract. So we'd have 1 dot for the income and utility you'd get if you're sick. You'd have another dot for the income and utility you get if you're healthy. Now we want a single dot to show us a person's income when they're sick, a person's income when they're healthy, and their utility level. And we want all of that information, again, about a single contract, insurance contract, to be nested inside that 1 dot. Okay, so I'm going to give you some examples of how we're going to do this translation, and then hopefully it will kind of clarify some things. So first of all, to begin with, let's start with the old setup. And let's suppose that there's a person who has an income of 10 if they're sick, and they have an income of 50 if they're healthy. Okay, let's translate that over to the new space. In the new space, the vertical axis is a person's income if they're sick, so we want it to be 10, so we just go up 10 units. And then the horizontal axis in the new space is a person's income if they're healthy. We want it to be 50, so we're just going to go over 50. And now that new dot is going to correspond to what the 2 previous dots used to be in the old setup. Okay, now let's suppose that this person is offered an insurance contract that is fair, but it's not full. So their income volatility is going to be erased a little bit. And now let's suppose that a person, if they get sick, has an income of 20, and if they stay healthy, they have an income of 40. Okay, we can translate that over to the new space. An income of 20 when you're sick means we simply need to take the one dot that we're now going to work with and move it up 20 units. And an income of 40 if you're healthy means that that dot needs to be moved over to the right 40 units. Okay, last kind of example here. Let's suppose a person is offered full insurance, and the full insurance is such that no matter whether they're sick or they're healthy, they have an income of 30. In the new setup, that means your IS needs to be 30, your IH needs to be 30, and we're now going to be looking at the final blue dot, which would correspond to the previous blue dot in the other setup. Okay, two things to kind of note. The new graph represents the key insights that, number one, insurance contracts transfer income from the healthy state to the unhealthy state. Okay, think about what this means now. So first of all, when you're uninsured, the income that you have when you're healthy is pretty big relative to the income that you have when you're sick. But when you get insurance, then it kind of beefs up the amount of money you have in the sick periods of your life, but then it takes away some of the money that you have in the healthy periods of your life. So it kind of like levels the playing field. Okay, we can see that in the new graph very clearly, because as you move from the black dot to the green dot to the blue dot, which corresponds to a person getting more and more insured, well, what happens? Those dots, first of all, are moving left, so the person's healthy income is falling. But those dots, when you move from the black to the green to the blue, are moving up, so the person's income when they're sick is increasing. So we're just kind of shifting money out of the healthy state and into the sick state. Okay, the second insight is that as insurance contracts move from partial to full, IH and IS converge. Okay, the way this is very easy to see in the new graph is that as you move from the black to the green to the blue dot, you're moving from no insurance to partial insurance to full insurance. And what is happening? Well, the two coordinates are becoming more similar to each other. So in other words, the first dot, the black dot, is at a place where your sick income is 10, your healthy income is 50. 10 and 50 are very different from each other. But then as you move to partial insurance and you move from IS of 20 to IH of 40, well, 20 and 40 aren't as dissimilar from each other as 10 and 50. And similarly, as you get full coverage, you move up to the blue dot, you get $30 no matter what your health condition is. And so 30 is very similar to 30. So in other words, the gap between your income levels starts to diminish as you get fuller and fuller insurance. Okay, that gives us the first very important thing that we get from the Rothschild-Stiglitz model. That is the full insurance line. Okay, if you draw a 45-degree line through the new IHIS space, then what you're going to get is a line where every coordinate along the line is sitting at a position where the IS is exactly equal to the IH. So along the 45-degree line, you're going to have one dot at 1010, you're going to have another dot at 2020, you're going to have another dot at 3030, and so forth. So along that line, what is true is that it doesn't matter what a person's physical health is, they're going to be making the same amount of money whether they're healthy or they're sick. So in other words, if an insurance company offers a person some insurance contract, and that insurance contract would yield income combinations such that if you plotted them, they exist along the 45-degree line, that means that that insurance contract is necessarily full. Because again, what is full insurance? It's just insurance where there's zero volatility in your income. Like your bank account is not at all tied to your health condition. And that is true for any contract that might reside along this 45-degree line. Hence, we're going to call this 45-degree line the full insurance line. Okay, big thing number 2 in this chapter is the zero profit line. Okay, to understand the zero profit line, what we're first going to do is we're going to think about a person, and that person, if they're uninsured, they're going to make some amount of money if they're sick, some amount of money if they're healthy. We can plot that event by plotting IS, and then I have a superscript U for being uninsured, and we can plot that against our IHU. So this would be like the black dot on the screen. Okay, what we learned previously is that for each person, they're going to have some expected or average income based on their probability of getting sick and what their sick income is and what their healthy income is. So we can use the expected income formula to calculate the person's expected income, and we can plot that on the same space where we just have their expected income along both the vertical axis and the horizontal axis, and that would correspond to the blue dot. Okay, what you need to think about now is if you took a line and you drew it straight from the black dot to the blue dot, then along that line there's going to be a whole bunch of different coordinates. Okay, what is going to be true, I'm going to tell it to you first and then you can try to mentally dismantle it, is every coordinate that exists along that line is going to correspond to an overall average income level that is the same as the average income level the person was getting when they were uninsured. So it's very clear to see this if you just compare the blue dot to the black dot. So by construction, average income, if you get the blue dot, is going to be exactly the same as the average or expected income if you are jumping between IS and IH, which is the black dot. And it's going to be true if you move straight from the black dot to the blue dot, that any dot along that line that you have drawn is going to follow the similar pattern. Okay, so let me kind of explain this in one other way in case you didn't catch it, and then we'll delve a little bit deeper. So the idea is, suppose a person is offered an insurance contract, and when you plot the income combinations that that insurance contract would give you when you're sick and you're healthy, you get some coordinate that exists smack dab in the middle between the black dot and the blue dot. Okay, what's going to be true is because that contract resides along the zero profit line, that contract would not be expected to make a person any richer or poorer than if they had no insurance. And the same is going to be true for any contract that's offered along the zero profit line. Okay, if you think back to previous definitions, what we said is that if insurance is fair, or in other words, the insurance company is not exploiting the customer and making money off of them, then expected income for the customer should not change as insurance becomes fuller. So as insurance becomes fuller in our new setup, you're just moving from the black dot to the blue dot. And so if that's what's happening along the zero profit line, then that means all of the contracts that are offered along the zero profit line are fair because the customer is not making or losing money and it's fair. In turn, the insurance company is not making positive profit or negative profit. They're expected to make zero profit if they offer a contract that resides along the zero profit line. Okay, now let's just think about fairness a little bit. So if all of the fair contracts sit on the zero profit line, then consider a contract that's off of the zero profit line. So for example, consider a contract that coincides with the X that I have on the screen, which is straight above the blue dot. Okay, that X is not on the zero profit line. That means that that contract would not be fair, or in other words, it would not leave a person equally as rich as they were before. Either it would make them richer or it would make them poorer. So let's try to sign this and decide whether or not that contract, if the person got it, would make them richer or would make them poorer. Well, okay, if we start at the blue dot as a baseline, if a person is offered the X, well then what would be true is that their income when they're healthy would be exactly the same under the X and the blue circle. But in the event they got sick, they would make more money with contract X than they would with the blue contract. So what we can say is that the X would make a person richer than they were at baseline if they were offered that contract. And so technically this isn't really fair, because now the person is kind of making money in this game. And so what's going to be true is that above the ZPL, or above the zero profit line, the person's income is more than when they were uninsured. So in other words, relative to both the blue dot and the black dot, any dot or any contract that's offered that's above the zero profit line is going to result in the person becoming richer than when they were uninsured. Okay, it works the same in reverse. So consider another contract, the second X, that is off of the zero profit line, but now it's below the zero profit line. Okay, let's compare how rich the person is with this X to how rich they were with the blue dot, which left them equally as wealthy as when they had the black dot. Okay, if we're comparing the blue dot to the black X, then if the person gets healthy, both of those contracts would leave them equally as rich if they're healthy. But in the event that they got sick, they would be making more with the blue dot contract than the X contract. And so this second X that exists underneath the zero profit line is going to leave a person poorer than before. So what's going to systematically be true is that below the ZPL, or below the zero profit line, the person's income is less than when they were uninsured. So kind of just mentally try to ingest this a little bit. The idea is the person starts out with no insurance. They're at the black dot. If an insurance company offers them any contract, and when you plot the income combinations that that contract gives them, if the residual contract exists along the zero profit line, then that insurance contract, it wouldn't really change their bank account. It would just be kind of fairly shifting income from the healthy state of their life to the unhealthy state. But if the insurance company offers them a contract, and when you plot the income coordinates that go with the contract, and you get some contract that exists above the zero profit line, then the person, they're going to definitely want to jump on that contract, because if they buy that insurance, they're going to be expected to be making money, more money than they were before. But on the other hand, if the contract, when you plot the income combinations that it yields, leads to some contract that's below the zero profit line, then the customer is definitely going to want to steer clear of those contracts, because it's going to be expected to make them poorer than when they started this whole game. Okay, if that's true of the customer, then the reverse is going to be true of the insurance company. So what we can see is that if a person is expected to be richer, if they're expected to be making money, then there's only two players in this game. There's the people who are buying the insurance, and there are the people who are selling the insurance. So if the buyers are making money, then that means the sellers of the insurance companies, are going to be losing money. So therefore, northeast of the zero profit line, the insurance company makes an expected profit that is less than zero. And southwest of the zero profit line, the insurance company makes expected profit greater than zero. So in other words, the whole region above the zero profit line, or off to the northeast, it's going to be good news for the customers of insurance. It's going to be bad news for the insurance companies, because in that region, the insurance company is going to be expected to lose money, because the money's going in the pockets of the customers. So in that region, the insurance company is going to be expected to lose money, or in other words, they're going to be expected to have a profit that is negative or less than zero. But if you go on the other side of the line, then the customers are losing money underneath the zero profit line. Therefore, the money they're losing is going to the pockets of the insurance company. So the insurance company is going to be expected to make a positive profit. So their expected profit is going to be greater than zero. Okay, final thing for this part of the chapter. Again, one thing that we wanted to be true is we wanted all the information that previously existed in the old graph setup where we plotted utility against income. We wanted all of that information to be somehow represented in our new setup where we're plotting IH against IS. So one thing that we had in the old setup was we had utility levels that corresponded to different insurance contracts or different income levels. We don't want to lose that piece of information. So in the old setup, it was very easy to see how happy a person was with a given income level because the vertical axis was literally happiness levels or utility. So what we're going to do is we're going to think about how do we, in this new space, kind of eke out the information about how happy a person is with a given insurance contract. So to do this, we're going to think about preferences. Okay, again, in the graph, we must be able to convey the notion that some contracts generate more utility than others. And we're going to do this using indifference curves. Okay, so consider the 4 following possible insurance contracts that are on the screen. We have insurance contract A, B, C, and D. Okay, let's just do a head-to-head comparison of contract A and B, and let's think about which contract would make a person happier, given that people like income. So the more income you give a person, the happier they are. Well, what's going to be true is that a person is always going to get more utility from B than they are from A. And the reason for that is because if you compare A and B, well, then if a person gets sick, then A and B will give them the same level of income. So IS is the same across A and B. But if a person happens to stay healthy, then if they have contract B, they're going to have more money than if they have contract A. And more income makes people happier. So B is clearly going to yield more utility than contract A. Okay, now let's do a head-to-head comparison of contract B and contract D. Okay, which contract would yield a higher level of utility? It's going to be B, because if we're comparing how happy a person is if they have contract B or D, well, if they stay healthy, then those 2 contracts give them the same level of income, so they wouldn't really have a preference between those 2 contracts in the event they stay healthy. But in the event they get sick and they're going to have to take home some level of IS, contract B is clearly going to give them more income, so they're going to have more utility from contract B if they're sick than they'll get from contract D if they're sick. Okay, so what this means, if we put indifference curves into this space, is that B is going to be on a different indifference curve than A and D, because B is going to yield a different level of utility. So people are indifferent between A and D relative to B. And so we can use these indifference curves to help us deduce how happy a person is from a given insurance contract. And specifically, when we overlay these 2 indifference curves, we see that contract B yields higher utility than contracts A and D because it resides along a indifference curve that's further out to the northeast. Okay, to just double down on this, let's do this one more time, but also consider how this would relate to contract C. Okay, to start with, let's compare how happy people would be between contract A and C. Well, people would be more happy with contract A than they would with contract C, because if they got sick, A would give them more utility. So we know that A is going to be preferred to C in terms of utility levels. If we compare C to D, then what's also going to be true is that people are going to get more utility from contract D than they are from contract C, because in the event they stay healthy, then if you look at the horizontal axis where you're plotting healthy income levels, contract D would give them more income than contract C. Okay, so again, thinking about this in terms of indifference curves, A and D are going to be on a higher indifference curve than contract C. And so what we can, again, figure out is that contract C is going to lead to less utility relative to a person getting contract A or D. Okay, so again, just to make this super explicit, hopefully, in the old setup, we could just look at the vertical distance of a dot and we can see what a person's utility is. We don't have that crutch anymore, but we still want to understand how much happiness people get out of given contracts. So we're going to figure that out by just overlaying indifference curves in this new ISIH space. And then depending on which indifference curve intersects the contract or the dot we're looking at, that is going to tell us how happy a person is with that insurance contract. And if we're comparing multiple contracts, we just look at the different indifference curves that run through each of those contracts, and whichever contract hits an indifference curve that's higher, that contract is going to yield higher utility. Okay, so that's a lot for today. If anything is confusing, let me know in the next 10 minutes. If you're so confused you don't even know what questions to ask, tell me that in the next 10 minutes, and I'll try to hopefully iron out some levels of confusion. And then after that, we'll do a practice so that you can get a little bit of work seeing how all this ties together. So after 10 minutes, I will meet back with you. Okay, for the exercise today, I want you to suppose that there's a person, and when the person is uninsured, when they are sick, they have an income of 100, and when they are healthy, they have an income of 500. And also suppose that this person has a probability of getting sick such that their P equals 0.2. Okay, question number 1 is I want you to calculate this person's expected income. To do this, you use the same math that we've used previously. So expected income equals the probability of getting sick times your sick income plus the probability of staying healthy times your healthy income. So nothing new here. After you have calculated their expected income, what you need to do next is you need to draw the person's zero profit line. You don't have to turn in this drawing, but you need to have it just so that you can proceed with the rest of the questions. Okay, note when you are drawing a zero profit line, you need to have a person's income when they're healthy along the horizontal axis, and you need to have IS, or their income when they're sick, along the vertical axis. Again, the two kind of points that peg the location of the ZPL are the person's income combinations when they're uninsured, and then the person's expected income. So you're going to need question 1 to draw the ZPL. Okay, once you have the zero profit line drawn, question number 2 is you need to answer what the slope is of the zero profit line. So you can just whip out the graph that you've drawn. That graph should have 2 dots on it. You can just count up and over to get the rise over the run. And for number 2, it just should be a number that you respond. So the slope of the ZPL line that you drew. Okay, question number 3 is suppose that an insurance company offers this person a contract that yields an income of $300 if they're sick and they have this insurance, and it yields an income of $300 if they're healthy and they have this insurance. Okay, the question is, would this contract be in the profitable or unprofitable region for the insurance company? Okay, so to answer this question, the easiest way to do this is to take out the graph that you've drawn that has the ZPL on it. In that graph, put a coordinate at 300, 300, and then look at whether that coordinate is above or below the zero profit line. Recall that any coordinate that is above the zero profit line is in the unprofitable region for the insurance company, because the insurance company is making an expected profit less than 0. Anything that's below the zero profit line is in the profitable region for the insurance company because they're making an expected profit that's greater than 0. So again, just make sure you have 3 answers turned in. So expected income, slope of zero profit line, and whether the contract that I've given you is in the profitable or unprofitable region. I acknowledge this part of the chapter is a little bit mentally intensive, so kind of go back and study this exercise once you get the solution to make sure it's especially clear to you, and then definitely read the textbook this chapter. So good luck studying and good luck on the exercise, and I'll talk to you next class.